Number 2, solving a right triangle. Directions: solve the right triangle, round decimal answers to the nearest tenth. So keep in mind, solve the right triangle means we have to find all the missing sides and all the missing angles. So I'm taking a look, and it looks like, first of all, I need little baby c, I need big angle b, and I need big angle a. Those are all the pieces that we're missing, so those are all the pieces that we need to find. I'm first going to start, I'm going to look at it, and I'm going to go, okay, this is a right triangle, little side c, probably the easiest. We could use Pythagorean theorem. So 3 squared plus 2 squared equals c squared. 9 plus 4 equals c squared. 13 equals c squared. Take the square root, grab your calculator. We could leave it in exact form, which I would prefer, but the directions say round decimal answers to the nearest tenth, so we're going to do that. And I'm getting c is 3.6. Okay, from there, I know this is 3.6. We now need to get angle A, and we need to get angle B. I do know that all the angles in a triangle add up to 180 degrees, but at the moment, I don't have enough information to go with that, so I'm going to pick angle A or angle B, it doesn't matter, and I'm going to go with angle B. When I'm doing a trig ratio here, we've got an opposite side, an adjacent side, and a hypotenuse. You just found the hypotenuse is 3.6. Keep in mind that is a rounded answer, so if you can avoid it, don't use 3.6 to calculate anything else. So I'm just going to consider the 3 and the 2. From angle B, opposite side, 2. Adjacent side, 3. So, ka, toa. If I'm dealing with an opposite and an adjacent, I'm dealing with a tangent. So, tangent of the angle is angle B, equals the ratio of opposite over adjacent, 2/3. Now, in this equation, the variable is b, and we're solving for a missing angle. So I repeat, you only use an inverse sine, cosine, or tangent if you're solving for a missing angle. Never use an inverse if you're solving for a side. In this case, we are trying to find an angle. So in order to get rid of a tangent, we're going to do an inverse tangent. Tangent and inverse tangent are going to cancel. Angle B equals the inverse tangent of 2/3. I now have angle B by itself, so I'm going to grab my calculator. Inverse tangent, 2 divided by 3, control enter, 33.69. Like I said, I would probably prefer you to round to the nearest whole number here, but the directions said nearest tenth, so 33.7 degrees. Okay, and keep in mind, put a degree on that, it is an angle. So 33.7 degrees. Now, at this point in time, you can kind of go 2 different ways. I know angle C is 90. I know angle B is 33.7. Angle A. So you know that little conversation we just had where I said don't use a rounded number to find a last number? It doesn't really apply with angles. And the reason is that angles always, no matter what, have to add up to 180 degrees. So whether I use another trig ratio or whether I just add them up to 180 degrees, it doesn't matter if one's rounded and one's not. So at this point, I'm going to do 180 minus 90 minus 33.7. Going to grab my calculator. 90 minus 33.7, which is going to give me 56.3. So angle A must be 56.3 degrees. And you've solved the triangle. Now, just out of curiosity, I kind of want to check that because I'm that kind of person. So, if I were to do it the other way, angle A, from angle A, this is now the opposite. This is now the adjacent. I'm still dealing with opposite and adjacent, so I'm still going to do a tangent. So I could do the tangent of angle A equals opposite over adjacent. I'm solving for a missing angle, so I could do an inverse tangent. Inverse tangent cancels tangent. A equals inverse tangent of 3/2. I'm going to grab my calculator. Inverse tangent, 3 divided by 2, control enter, 56.309, which, 56.3. There we go. Example B. Okay, so once again, solve the triangle, so we have to find all the missing sides, all the missing angles. I'm going to put an X here. So we have to find X, we have to find angle H, and we have to find angle G. Looking at this triangle, it's very similar to the one we just did. So I'm going to start the same way, and I'm going to use the Pythagorean theorem to find X. So 91 squared plus X squared equals 109 squared. So 91 squared is 8,281 plus X squared equals 109 squared, 11,881. X squared equals minus 8281, 3,600. Take a square root, 60. So now I know this side over here is 60. Now, just a little reminder, take a look at 109, take a look at 91, take a look at 60. Do they form a Pythagorean triple? The answer to that question is yes, because remember, a Pythagorean triple are three numbers that satisfy a squared plus b squared plus c squared that are whole numbers. They can't be decimal numbers. So in this case, we have a Pythagorean triple. Moving on, we can either find letter H, angle H, or angle G. Again, doesn't really matter. I'm going to start with H. Now, think about this for a minute. Would it be okay if we use 60 to find angle H? Answer to that is yes, because 60 is not a rounded answer. It's exactly 60. But just to be a little bit different, I'm going to go with the 91 and the 109 anyway. So from angle H, 91 is my adjacent side. 109 is my hypotenuse. So, ka, toa, adjacent and hypotenuse, ka. So we have to do the cosine of the angle. The angle we're dealing with, angle H, equals the ratio of adjacent over hypotenuse. So 91 over 109. We're trying to find a missing angle. So in order to get H by itself, I have to get rid of the cosine. The way we do that is we take an inverse cosine. Inverse cosine cancels cosine. H falls out. Then we have the inverse cosine of 91 over 109. And then grab your calculator. So inverse cosine 91 divided by 109, control enter, 33.4. Last but not least, we need to find angle G. So I'm going to do the same thing that I did before. So I'm going to take 90 degrees, I'm going to subtract 33.4. That gives me 56.6, which is my last angle, and we're done. One more, letter C. So if we take a look at this guy, all the missing sides, all the missing angles. It looks like we're going to need to find side little g, side little h, and big angle G. Think about that for a minute. So the first thing sticking out in my head is right here. In this particular picture, we have two angles. We have a 90, we have a 25. All the angles have to add up to 180. So I'm going to take 90 minus 25, which gets me 65. So I know angle G, 65 degrees. Okay. Moving on. At this point, we can either find G or H, and in order to do that, I'm going to need a reference angle. I can use angle G because it's just 65 degrees, that's not rounded, but given what they gave me in the picture, I'm going to use the 25 instead. From 25, I know 13 is the hypotenuse. Then you get to choose. Do you want to find G first? Do you want to find H first? Really doesn't matter. I'm going to find G first, which is the adjacent side, if I'm comparing that to the 25 degrees. So, ka, kawa. Adjacent and hypotenuse, right there. So we're going to use a cosine. Cosine of 25 equals adjacent over hypotenuse. Now, look at that equation really closely. Should I take the inverse cosine of both sides? That little cosine -1 thing. Should I do that? I hope you're shaking your head no, because in this case we are not trying to find a missing angle. We're trying to find a missing side, and you don't use inverse trigonometric functions in order to find a missing side. So at this point, we're going to revert back to what we've done before. We're going to put this over 1, and we're going to cross multiply. So 1 times G equals 13 times the cosine of 25. At this point, I have the G by itself, so I'm just going to grab my calculator. We're going to type 13 times the cosine, 25, control enter, 11.8. That is a side. Don't put degrees on it. Then I'm going to go back up here, 11.8. Okay, at this point, I know the hypotenuse is 13. I know that G is 11.8. All I need is H. Should I use the Pythagorean theorem? No. So when you're dealing with angles, it's okay to use a rounded angle to find the last angle. They have to add to 180 degrees. When you're dealing with sides, try to avoid it. Okay, so I'm going to go back. I'm going to use another trig ratio. I'm going to keep the 25 degrees as my reference angle. I know that 13 is my hypotenuse, but from 25, H is now my opposite. If I'm dealing with the opposite and hypotenuse, that's going to be a sine. Sine of the angle, 25 degrees, equals the opposite side over the hypotenuse. Once again, have a conversation with yourself. Are you trying to find a missing side, or are you trying to find a missing angle? Because we're trying to find a missing side, do not use an inverse trig function, just basic cross multiply. So 1 times H is H equals 13 times the sine of 25, and then grab your calculator. So 13 times the sine, 25, control enter, 5.5. And